I want to look at a couple examples of quadratic equations just to show their usefulness. So our first question is, Ben's train traveled 576 miles, averaging a certain speed. If the train had gone 8 miles per hour faster, the trip would have taken 1 hour less. Find the average speed. Okay, so the trick is here, we have to understand what we mean by average speed. So for example, if we drove a distance of 576 miles, if you divide that by the time it took to get there, you get your average rate. We'll call it R. So in other words, 576, the distance traveled, is your rate times time. Okay, now, so we know that 576, the distance traveled, is rate times time. We also know that I could cover that same distance if my rate had been 8 miles per hour faster, so R plus 8, with a time of 1 less hour, so t minus 1 hours. So I know that 576 equals rate times time. I also know that 576 equals R plus 8 times t minus 1. Okay, and actually here what I'm going to do is I'm going to use the substitution to eliminate the variable R into this expression here. Alright, so what I mean by that is I'm going to say that 576 equals, instead of R plus 8, I'm going to say 576 over t plus 8 times t minus 1. So when I multiply that out, I have a 576 times t, so now I'm foiling this out. That gives me a 576 t over t. The t's cancel out, and I can do that because t will definitely not be 0 here. Then I have a minus 576 over t. I have a plus 8t, and I have a minus 8. So when I finish this equation, my result becomes the equation 576 equals, well, this became 576 minus 576 over t plus 8t minus 8. Okay, now subtracting, I get the 576's cancel on each side. So then I end up with 0 equals this negative 576 over t plus 8t minus 8. Alright, now what I can do here is multiply both sides of my equation by t. And when I do that, I end up with the equation, well, t times 0 is still 0. I end up with 8t squared minus 8t minus 576t over t, which is minus 576. And I rearranged it so that we'd have our terms in descending order, which we typically like. Okay, so from there, I divide both sides by 8. And now I have a simple quadratic equation. I have 0 equals t squared minus t minus 72, which we know if you're trying to factor this thing, you need two things that multiply to give you negative 72 and add to give you negative 1. If you think about it for a little bit, you'll get t minus 9 and t plus 8, which gives me the results t equals positive 9 and negative 8. Now if we think about it for a moment, we're dealing with time, so negative 8 doesn't make any sense. So we're going to go with the time is 9. But that's not what the question was asking for, right? The question, if you think back to the beginning, was asking for average speed right there. So we're looking for this R, but we have this relationship, 576 over t equals R. So my R that I'm looking for here is my 576 divided by 9, which is 64, and that's in miles per hour. I hope that makes sense. If you have any questions, just leave a comment. I'll be glad to help. Alright, let's look to another example. So here it says find the y-coordinates of the points that are 10 units away from the point 76 with x-coordinate 1. Okay, so we can actually picture this geometrically, what they're talking about. So here you're at the 0.76 somewhere up here, and if you take a radius, a circle, I'm sorry, with radius 10, and that's not a very good circle, but you get the idea. And if I take the y coordinate -1 down here, I'm looking for the points where that circle crosses that line, okay? And the way the line truncated here, this looks a little confusing. I do mean -1. All right, so we're looking for x equals -1. Now the way I do this is by using this formula. The distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 quantity squared. So in this case, I have a distance. My distance is 10. And actually I have a lot of other stuff. I have an x and y coordinate, so I can say maybe the x2 is 7. And actually I know my other x coordinate, right? My other x coordinate's at -1. So that's going to be 7 minus -1 squared plus, I have a y2, that's the 6, minus, we don't know the y1, so let's just call it y, quantity squared, okay? And so now I just have to solve this equation, and hopefully we can figure out what these two coordinates are. Alright, so what I would do, since there's the square root, is I would square both sides. And so I get 100 on one side, and on the other I have 7 plus 1 quantity squared, so that's 8 squared, plus 6 minus y quantity squared, so 6 minus y times 6 minus y. For the scratch, you get 6 times 6, 36. You get negative y times 6 and negative y times 6, so you get a negative 12y. And then you have negative y times negative y, and you get y squared. Okay, so if you think about it, 8 squared is 64 plus 36, that is 100. So if I subtract both sides, if I subtract 100 from both sides, I get 0 equals a y squared minus 12y. This factors fairly easily. You can take out a y, and you get a y minus 12. And so there I have it. My solutions then are y equals 0 and y equals positive 12. Okay, now what you'd want to do here is, since there is some place where we should have kind of put a red flag, so to speak, and that's right here. I squared both sides of my equation, and when you do that, there's the possibility of creating an extra solution that's not a real solution. So what you'd want to do is take both of these points and plug them back in to see if they solve this equation. And by the nature of this thing, they should. Okay, now that we've done this, we start wondering, well, do we have the actual coordinates? It only asks for the y coordinates here, but can we find the coordinates? And the answer is yes, because we already knew the x coordinate was -1. So then my two points on this circle are -1, 0 and -1, 12. And that's what these two little points here are. Alright, I hope this makes sense. If you have any questions, please let me know. I'd be glad to help. You can leave them in the comments or just get a hold of me. And thanks for watching.